Good afternoon, everyone, and welcome to the ITV Tech Forum. I'm your host, Tom Clark. This is your almost monthly opportunity to kind of get together as a group of geeks and actually kind of hear interesting technical topics from people inside and outside the organisation. Today we're delighted to have Carlos Teixeira from the Scala teams to be talking about distributed tracing. So please put your hands together.
Thank you. So hi everyone. Let's just wait for everyone to get in very quickly. Cool. So we'll be talking about distributed tracing and metric collections in Scala. So just a small summary of what we're going to do today. We're going to start by looking at a small project that I built, which intends to display some of the capabilities of a library called Kaman, which allows us to do a lot of distributed tracing and metric collection in our services. We're going to do a small demo of that project working, and we're just going to, after that, introduce a couple of concepts that are a bit important, and then we're going to see how Kaman works and how we can effectively do this metric collection and tracing in our application. And then if there's time in the end, we can do some questions and answers. And yeah. So welcome to foobar. So it's our functional object-oriented bar. It's a project I've been doing on my free time. So we have fully automated taps. They're mostly non-alcoholic because we don't want people screaming at tech that doesn't work when they're drunk. So the bartenders are fully automated as well. And then the user interfaces are just terminals because I'm a backend engineer after all. Sorry to disappoint. So the way foobar works is client comes in, he or she fires a request to the console app. The console app will just essentially forward that request with the drink type that the customer wants to a bartender app, which will just generate a unique identifier for that request, and will essentially publish that request into a RabbitMQ. The bartender will then respond to the console with the drink request ID, and then that will get shown to the customer as well. So on the other end, we have a couple of taps bounded to our RabbitMQ instance, and essentially they'll take an event for a drink request and they'll just pour a drink afterwards, which in this case is just, it will just sleep for a couple of seconds. Then the water tap publishes something into Rabbit again, saying this drink has been, the drink has been poured, which gets sent back to the bartender, which then does a patch request to the console saying that specific drink request is now fulfilled. And at any point, the client can just query the console to try and find the status, and at some point it's going to be successful. So small demo of this thing working. Again, just what? No. Sorry. So just do a curl request to HTTP requests saying I want a pint of water or something. And then here in the bottom we have the logs of our application. And we can see that the request has been through. And if we check the status of the request now, let me just see. Okay. If we check the, oops. Sorry. Okay, that's okay. Yeah, so it's been successfully poured because I think it's only sleeping for like 200 milliseconds. So yeah, so everything is all right. Like our application is running, but what's happened here? Cool. Our application is running, but we don't really have a feel of how things are going. Like we don't understand if things are up or down, if they're taking too long to answer, or how are things effectively doing in our platform. So hopefully we would like to have some kind of monitoring around our applications. By monitoring, we might be monitoring different things. So like we may want to know if our service is up or if it can connect to databases or RabbitMQ or to other services. But that's really not enough. We may also want to know how long it's taking us to respond to certain requests, and how long is it taking to query the database, or how many errors is it throwing in the process. And hopefully, if you have that data, you want to have some kind of thresholds, which if at some point they get the values get over those thresholds, you get some kind of alerting. And once you get alerted for a problem, you want to go in and be able to understand what the problem was. And at that point, you want to be able to have a more contextual view of what's going on in your project and where the error is actually coming from. So I'm going to show you how to do that, but before, there's just three important concepts that I'd like to clarify, because I'm going to be bringing them up quite a lot. So we have span, trace, and context. The idea is, so a trace is essentially identifier for a transaction within your service. So it would be the same identifier across service boundaries. Within this transaction or trace, you'll have spans, which are just things you want to be looking at. They could be, they're generic, so it could be a single HTTP request, or just could be a single function call, essentially whatever you would like them to be. And then associated with any span, you want to have a context to understand what's going on. So maybe some parameters that you pass to the function, or some values for the HTTP request you're processing at that point. And just to illustrate that, let's say we have two services, A and B. Service A starts executing, and you see that it generates a new trace ID, because this is a new execution that's starting. It's going to generate its own span ID, and it's going to generate a context. In this case, let's pretend like this is an HTTP request. So it's going to generate, maybe it's going to keep like the URL, maybe when it's over, it's going to store the status code, and some other things we may be interested in. So during execution, service A is going to call service B. And because we want to know for service B what's in which context it was called, it's going to send along a trace ID and a span ID. So the span ID is just an identifier of the parent operation, and the trace ID will essentially identify the entire transaction across your services. Service B will then generate its own span ID, which identifies the execution within service B, and again, its own context, because this is another HTTP request. We'll then return back to service A, and just to clarify, if service A were to call service B again within the same transaction, we'll still send along the same trace and span IDs, because this, from service A standpoint, this is a viewpoint, this is still the same trace and span, but service B will then generate a new one, because it's essentially processing a new request. And that's it. So let's see what this can give us. So I have this project set up here, which was the one you just saw. I'm running it using Docker Compose. You can see that we have our bartender here, a couple of tabs, console, and tab, and yeah, that should be it. So we're going to start by sending a, oops, not private keys. Okay, so I've had this small script, just going to start firing requests to our application. It's going to fire 1,000 requests for each type of drink, and it's going to have at most 3 requests active at any given time. So let's just start firing up this thing. And I mean, it seems like it's going well, because everything comes out as processing and we haven't any errors, but we'd like to see, like, how is our application actually running? So let's go here. So because I've integrated this with Common, and because Common in our service is publishing data related with our services execution to an InfluxDB, we can just hook up Grafana. We can just hook up Grafana to our InfluxDB instance, and we can get some data out of it. So let's. So I've created a couple of dashboards just to so that we can see what type of things we can extract. So let's look, for instance, at the console app. And we can see in the console app that so one of the first things that I've added was, so for each type of operation in our console app, so for instance, this first one is the post drink request endpoint, or the patch drink request followed by a UID endpoint. We can also see like this update query and generic executes are metrics related with the execution time of queries in the database. This particular piece here just gives you like the max amount of time it took for each particular operation. This in the last 5 minutes. You can actually increase it a bit. We can also see the throughput of requests. We can break it down by, in this case, by so the operation is essentially the URL. So we can break it down by URL. We can also we could have filtered those out, but you can see if there was errors. We can actually see that there seems to have been a couple of errors in the beginning. Again, response times broken down by, in this case, the method. We can actually, in this case, it's a 99.9 percentile, so we can compute averages, percentiles, or whatever we're interested in. Again, status counts based on the operation name. One thing we can see here is that there seems to be a 500 error somewhere for the. So this is the request that this is the endpoint that creates the drink requests, and then this would be the execution times for requests out of our services to, in this case, to the bartender services. Query times, again, in the context of we can break it down in the context of the endpoint that it's being executed on. We can get JVM memory usage, JVM threads, executed tasks. I mean, some of them still don't know what PS mark sweep in the garbage collector is, but we can get all of this out of our services. So we have console. We also have another one for bartender. Pretty much the same thing. The difference here is we have a RabbitMQ instance. We're using Bucky, which is one of our libraries, one of our client libraries for Rabbit, and we can get the time it took to write for specific routing keys or exchanges. We can also plot the time it took to read things and process things from Rabbit, and again JVM threads, memory usage, and so on. And then the one for tabs is pretty much the same thing, although the tabs only use RabbitMQ, but we can see again broken down by type of routing key here, the maximum time, or plot whatever we need. So another thing, so now we know that our service seems to be running more or less fine, but we still had those issues in the beginning. We seem to have found here, if you look quickly, and let's maybe take half an hour. It seems like there was some 500s here, which are, I mean, they're strange because everything seemed to go okay. So let's maybe look at Kibana and try to find service label. Let's maybe see if we can have some errors here. Let's maybe add the last 30 minutes. And you can see there was essentially two types of errors. This was in the beginning, which was the one we were looking for. Let's maybe look at this. And another thing that Kaman is doing is, remember that trace ID and span ID is including those in the logs as well. So we can add, where is it? Oh, this is weird. Let me just check one thing.
Got back before you listed the forum started.
Sorry?
That's a 5 to 2 when you first set up laptop.
What? I can hear.
The timestamp is 5 minutes to 2 before your talk started. That's when you first turned your laptop.
Damn it. Oh, okay, let's just.
You zoom out again. There's some on the right hand side.
Okay, let's try to find. Okay. So label error. No, this is fine. This is what we're looking for. It's just weird that I can't seem to find the trace ID. Oh, there you go. Sorry. So yeah, we can see that we have a couple of error logs, and we have a trace ID, which we can then use to isolate the logs associated with this call. So let's remove this error now. Let's add the message. Maybe add this thing. And what else was here? We want everything. Trace ID. Oh, and quick. Let's say last 30 minutes. Okay. This is trace ID. Last 30 minutes. So yeah. Anyway, we've isolated the logs for our specific requests. In this case, it's fairly simple to go through the logs. Maybe sometimes, but sometimes, like the logs themselves are, even if you scope them down to your particular request through your platform, it may get hairy at some point to go through all of them. So another thing that Commons allows us to do is to export traces and spans of our application into tools like Zipkin or Jaeger. So I've added Jaeger here, but it does have a couple of bugs, even though it looks better than Zipkin. So this would be Jaeger. We're going to be mostly looking at Zipkin now. And so at this point, we can see, it's actually not the best example, but we can see the console. The process started here, and it seems like it threw an error, which at this point was a post 500. We can see all the context around when did this start, what's the trace and parent span IDs. Here the console is calling the bartender app, followed by the bartender app starting executing. And it seems like at some point, so AMQP, for some reason, we failed to publish things into Rabbit. There's also other capabilities that this thing has. So we can filter by, let's say, we want to find examples of traces where the HTTP status is 500. HTTP, dot status code. And immediately we can see here, again, the same trace. So yeah, so this would be the kind of tools that Common allows you to integrate with. The next, one of the last things that I wanted to show is what's the work involved in integrating with Common. So essentially, what I did here was I've added a couple of modules to my build SBT. There's essentially three categories of modules here. The first one will be collecting metrics from our application. So the common executors will be collecting metrics around thread pools and execution context. Common HTTP4S, in this case, is going to take collect metrics from incoming requests and make sure that they get passed along to requests that go out of our application. JDBC is going to be looking at database and system metrics. It's mostly doing the JVM kind of monitoring. It also allows you to monitor things like CPU loads or RAM. But at this point, I think it has a bit of a problem with the Docker image I'm using, so I haven't gone through that path. Then we have a couple of reporters which are going to look at the data that's being collected, and they're essentially going to export it outside. Common logback is just going to include the trace IDs and span IDs in the logs. The Jaeger and Zipkin are going to export data to Jaeger and Zipkin, and the last one, the InfluxDB, is going to be exporting everything to InfluxDB. And lastly, the Common core essentially ties both of the modules together. So we're extracting data in the first ones. The data is being sent to the Common core module, which is essentially compacting it and making sure that we're not storing too much information. And then the reporters are going to be looking at the core part of the library and just extracting the data and sending it along. So that would be the first step. Then we have to add a couple of plugins to our build SBT. mostly because Common needs to have a Java agent and uses AspectJ to do this kind of thing. So we have to add the plugin so that the Java agent is added, and a couple of flags so that the Java agent is started with our application. Apart from that, application conf, because you may want to, so you'll see that a lot of the things are duplicated here, mostly because I provide the default and want to be overridden by an environmental variable. But most of them are just defaults of the library, so you don't really have to specify everything. So in the logbag XML, we just included a trace and span ID in the logs. There's not much more. And this is only for std out. For the logbag module, it's added automatically. And lastly, we just have to do some top-level changes in our application. So when we start our application, we're going to have to start some of the reporters. And specifically for the HTTP4S module, we're going to have to wrap both the client and the router of HTTP4S, so that Common is able to tap into incoming requests and is able to send information when we do requests to other services. And so client from and lastly, because this is not part of Common, I had to add it by hand, which is actually good because it showed me that you can add the module for Common quite easily. And this part is just monitoring by key and making sure we get information out of things that go into Rabbit and out of Rabbit. What else? We have to provide, again, a specific execution context. You can choose your own execution context again, but you're going to have to wrap it so that, you have to wrap it in a common execution context, so that whenever you change threads, like when you're using IOs or features or something, whenever you change threads, it makes sure that you're actually propagating the contexts properly. And the last thing you have to add is, a way to go from an URL to a more generic operation name. Because if you have an endpoint like client -1 or -2, you're not really interested in the individual URLs. You're only interested in the /client/ some kind of client ID. And yeah, let's just recap. Make sure you didn't forget anything. Build SPT, plugins SPT, main scala. It depends on how you set up a project, but it's very top level. You don't have to change anything in the actual logic of your project. Application conf, logbag, and then a way to go from URL to operation name. Lastly, Common doesn't only support HTTP4S. It supports. I actually already used the Play and ACK HTTP modules in my previous company. It also supports akka. Anything that really anything that uses futures. It's maybe you'll have to do some work to get information out of the packages, but then the propagation is handled by Common without you having to do anything. And then it's also able to, like we saw, collect data from JDBC and system metrics. And in terms of reporters, in this case, we're just using the InfluxDB one and the Zipkin ones, where it also allows you to export things with Prometheus, which was the one I actually used before, and Stats, the Datadog, and there's a couple other modules as well. And yeah, so the top thing is the repository I've built. You can check it out. You should be able to build it. You just have to have Docker and Docker Compose. There's no other dependencies. It will take a bit to build, but that's a given. And then just the Common website and a couple of podcasts I found useful while researching these things. And yeah, any questions?
When you talk about the context, particularly across the thread shifting, is that using MDC in the back end?
Using what?
MDC?
So it is using the MDC, but there's more behavior around it, so that because when you change threads, the MDC is gone. So essentially, command wraps the MDC and makes sure that whenever you change threads, you propagate the MDC correctly, and that you never get like an old MDC, or that you lose the MDC.
And when you talk about tracing being across boundaries, if we have a call coming in from the public and we touch 20 different microservices, will that trace ID need to be set at the next level or something in between?
So you don't really have to set it at any point. It's just that the moment you set it, you have everything downstream with that trace ID. Everything upstream, you just lose it. But like if your Nginx doesn't have a trace ID and then the next service has, then you're going to have a trace ID starting at that service.
And it will do all the propagation all the way through and back?
Yeah.
Thanks. So we kind of wrapped a load of like system relatively low level.
Louder.
Sorry, you kind of wrapped on some low level things like HTTP4S or
Yep.
the RabbitMQ bits. How about actually inside your application, inside a business call, like you purchase something on the ITV hub, a user presses a particular thing, how easy is it to actually emit like a business code?
Cool. So the way you do it, let me just give you an example, is let's say the project is not that. Let's say I'm interested in a specific call, I don't know, like this create client request. So you do something like common dot, I think it's operation something, with context with span. Oh, with span. There you go. So you do something like common with span. You give it a name. You run the thing inside, and then it just starts monitoring this specific call. Usually, the only thing that's not advisable to do is, so you monitor something like I don't know, a purchase, but it has to be more generic. If you start monitoring like purchase of specific things, then there starts to be an explosion of data being collected, and that's really a problem.
I suppose you make the object ID or something a key within the event, so the event can be purchased, and inside that there's key values that the key object type or item.
You can add tags to your spans, which I think is more or less what you're saying. The issue is that is then going to be sent, for instance, for InfluxDB. So you're going to start, so rather than just looking at an operation, you're going to be looking at a lot of operations, which is not very useful in some contexts.
Is there any, when you think of asynchronous transactions, like things that are powered by messages, is there any challenge with that in implementing it and in getting good visibility?
So there's one consideration there actually, which is we should. I don't really think we should be sending the trace. I did it for the sake of the presentation, but I'm not sure if we should be sending the trace IDs across rabbits, because it's the idea is that, I mean, it doesn't really make sense to look at the trace that's going to be like a week long or something. But the challenge, there's really no challenge. You just have to, Common allows you to tap into the current context, and then I just had to add the trace ID and span IDs to the message headers, and that's just it. And then when you read, you just take those headers and add them back to the current context.
It's interesting that what you've shown is pretty much part of the platform we have now, except for Zipkin or for the
yeah, it was part of the objective was to make. So I've used Common before with Hack HTTP and Play. It works pretty well. Like the previous company I worked, they've recently integrated it with Jaeger in that particular case, and it's been going there for I think the last 6 months, more or less. And they didn't have any issues so far. What I tried to do here, like I actually wanted to bring this to our team, and so I've done this pet project as a way to prove that we can integrate this thing with HTTP4S and with most of the tools we already have at ITV. Any more questions? that's it. Thank you, guys.
Thanks, Carlos. That was really, really fascinating. I mean, that's a technique I've kind of been a big fan of for many, many years, and online a few years ago we built something vaguely similar, but not quite as polished as that, pumping all the data into Splunk, and because of kind of the multivariate fields we had, you could do some very interesting kind of queries on that, and actually a bit more than log slash count, which is great, really, really cool. Cool, so that was the Tech Forum. There's still some donuts left at the back, but I think we'll be back again same time next month. Don't know what the talk's going to be yet, but I'm sure I'll find one. This afternoon we've got the Tech Social over at the Eastern. I think there's a table from 5:30 in my name, and you're all absolutely welcome. It's a great place to kind of meet new people, make new friends, welcome the new starters we've got on the team as well, and also kind of celebrate all the great successes we've had recently. So I hope to see you all there. Otherwise, I'll see you again soon. So thank you all very much.
Thank you.